Hello class 7. In the previous class you have read about the medians and the centroid of a triangle, and today you are going to understand the new thing, that is altitudes and the orthocenter of a triangle. So take a look at this. Students, our topic is altitude and orthocenter of a triangle. First of all, we have to understand the meaning of altitude. So, an altitude of a triangle is the line segment from a vertex of the triangle perpendicular to the opposite side. Here in this triangle ABC, you can see A is the vertex and AD is the perpendicular to the opposite side BC. So AD is an altitude. Likewise, B is a vertex and AC is the opposite side, and BE is the perpendicular to the opposite side AC. Hence, BE is an altitude. Similarly, CF is an altitude to the opposite side AB. So we can see here there are three altitudes in a triangle. Here in triangle ABC, AD, BE and CF are altitudes of the triangle. And now we have to understand the orthocenter. The point of concurrence. Point of concurrence means meeting point. The point of concurrence of altitudes is called the orthocenter of the triangle. You can see here all the altitudes AD, BE and CF meet at a point O. Hence, this point O is the orthocenter of this triangle ABC. So here O is the orthocenter of triangle ABC. Now, in a specialized case, for acute angle triangle, you can see here PQR is an acute angle triangle and PL, QM and RN are the altitudes, and all these altitudes concurrent at O. So the orthocenter lies in the interior of the triangle. You can see this point O is in the interior of this triangle PQR, which is an acute angle triangle. Now for right angled triangle, you can see here ABC is a right angle triangle and BL is an altitude to the opposite side AC. But now we are going to draw an altitude from the vertex A to the opposite side BC. We get the same line as AB and the altitude go through the point B. Again, when we are going to draw the altitude from vertex C, then we can see that the altitude coincide with the side CB and go through the point B. Hence, we can see that all the altitudes AB, LB and CB all meet at a point B, that is the vertex where right angle form. So we can say that the orthocenter lies at the vertex at a right angle. The orthocenter lies at the vertex at a right angle in a right angle triangle ABC. Now for an obtuse angle triangle. The orthocenter lies in the exterior of the triangle. How it is possible? The orthocenter lies in the exterior of the triangle. So you can see triangle ABC. Triangle ABC is an obtuse angle triangle in which angle B is obtuse. And when we are going to draw the altitude from vertex A, then we can see that we have to produce side BC towards M, and ultimately AM is the altitude to the side BC extended at M. Now when we are going to draw altitude from vertex B to opposite side AC, then BL is the altitude. BL is the altitude. Now from C, when we draw the altitude to the opposite side AB, then we can see that when we are going to draw altitude from C, we have to extend AB to N, and then we draw the altitude CN to the extended AB. Then you can see when we extend these altitudes CN to O, LB to O, and AM to O, and all these altitude when extended then meet at point O. Then the point of concurrence of these altitudes is O, which is in the exterior of the triangle ABC. Hence we can say that the orthocenter lies in the exterior of the triangle when it is obtuse angle triangle. Now for an equilateral triangle. If we draw an equilateral triangle and draw all the altitudes in this figure, ABC is an equilateral triangle, and all the altitudes AL, BM and CN are drawn, and you can see all these altitudes are same in length. So first thing is all altitudes are equal in an equilateral triangle. And again, the orthocenter and the centroid of an equilateral triangle are same. How? You can see if it is an equilateral triangle, this AL is median also. This BM altitude is a median also, and CN, the altitude is a median also. So all these altitudes are medians also. So the point of concurrence of medians or the point of concurrence of altitudes all are same. So this orthocenter is also the centroid of this triangle. Now for an isosceles triangle, here ABC is an isosceles triangle. You can see AB equals AC, and we draw AD the altitude, BE the altitude, and CF the altitude. But the altitudes drawn to the equal sides AB and AC are equal in length. That is, BE equals to CF. Altitudes drawn to the equal sides are equal. Now students, I think you much understand about the altitudes and the orthocenter of triangles. Actually, different types of triangles. You can also watch me on my YouTube channel, Ocean of Maths. Thank you. Thank you very much. Have a nice day.